Inferential statistics is how we go from a small sample to conclusions about an entire population. We can't measure every voter, every patient, or every star in the universe. So we take a carefully chosen sample and use mathematics to say what is probably true for everyone. Here are the 4 tools that make this possible. First, the sampling distribution. If I repeatedly take random samples of the same size and calculate the mean each time, those sample means form a bell curve centered on the true population mean. The width of that bell curve is the standard error. Second, the confidence interval. A 95% confidence interval means if I repeated this experiment many times, about 95% of those intervals would contain the true population value. It is not 95% chance the true value is in here. The true value is fixed, the interval is what moves. Third, hypothesis testing and p-values. We start by assuming nothing special is happening. The null hypothesis, if the data we observed, would be extremely rare under that assumption. Usually less than 5% chance we reject the null and say the result is statistically significant. The p-value is exactly that rarity number. Fourth, the margin of error you see in polls. It comes directly from the standard error and the confidence level. A poll of 1,000 people with 3% margin of error is just a 95% confidence interval. For a proportion, these 4 ideas, sampling distribution, standard error, confidence intervals, and hypothesis testing, are all different views of the same underlying mathematics. They are why a few thousand people can predict elections, why drug trials with a few thousand patients can change medicine for billions, and why science can progress without measuring everything. Inferential statistics does not give certainty. It gives rigorously quantified uncertainty. And that is the best we can ever do. Thank you for watching.